This is Arun Gupta. I, of course, work for Oracle, and I'm one of the Java EE evangelists at Oracle. I'm also called as the Glassfish guy. So today we are here to talk about Java EE 7. As most of you know, Java EE 7 is ready for release. We have scheduled an online launch for June 12th. 3, which says Java EE 6 key statistics. Yes, this presentation is about Java EE 7, but let's take a look at how well adopted Java EE 6 itself is. There are 50 million plus Java EE 6 component downloads, and I'm primarily talking about Glassfish at this point in time, which is the reference implementation of Java EE 6. I'm not even talking about all of those WebLogic, WebSphere, JBoss, Apache, and 16 or 18 compliant application servers that have been available for a while. This has been the fastest implementation of Java EE 6. So truly giving you the promise of write once, deploy anywhere. And Java EE 6 in that sense was a big step in the direction where a lot of functionalities were baked into the platform itself. And Java EE 7, going to the next slide, which is slide 4, is ready for release. June 12th, as I said, is when the launch is planned. And I will share more details in the email after this call. Now, there are 3 big themes for Java EE 7. The first one, as you can see in the middle, is sort of embracing HTML5 to its core. In that, basically, we're talking about providing first-class support for WebSocket, JSON processing, highly scalable applications that we can give you either using servlets or asynchronous REST endpoints, and I'll talk about all of those. The second big theme for Java EE 7 is increasing developer productivity. If you realize that was a theme that we started with in Java EE 5, continued big time in Java EE 6 with the introduction of CDI, and now in Java EE 7, we have done a much better job of aligning all the specs together. And I'll talk about all of those as we move along in the presentation. And last but not the least, Java EE is very well established in enterprise. We are adding some more capabilities to the platform to meet the enterprise demands. Primarily batch, API, concurrent utilities, and overly simplifying JMS as well. So I'm going to go through all of these, in the subsequent presentation. Going to slide 6. This is sort of the top 10 list for me in Java EE 7. And it may not be doing justice because, like, for example, the first one I'm saying WebSocket client server endpoints. Now, that's the entire JSR 356 specification. If I were to list features, within WebSocket itself, I can list 3 or 4 features maybe. But just to highlight, the ability that there is a first-class support for programmatic and annotated endpoint support, both client and server in Java EE 7 is pretty big. Then we also have support for inbuilt batch applications. And everybody we have talked to in terms of partners, customers, community, they've all been very excited with this. So this definitely reduces your dependency on third-party frameworks. Same thing with JSON processing. Now with JSON processing part of the platform itself, your applications could become much more lighter weight, where you don't have to bundle third-party libraries to do JSON processing. And then concurrency. So this has been a long pending item. As you realize, the JSR number is 236. All others are more in the 300 ranges, 340 ranges. So this kind of shows, how developers have been long waiting for it. But now you can leverage the existing concurrency APIs in a Java EE environment. We'll talk about that. So these first 4 points are brand new additions to Java EE 7. Then JMS API, the top fifth feature for me is simplified JMS API, how we have leveraged dependency injection to simplify it extensively. We'll talk about that. I briefly touched upon how we are doing alignment across the platform, and as a result, we have a new annotation called as transactional, new CDI scope called as transaction scoped, which allows you to convert any POJO into a transaction, into a transactional object, either the class or a method of the POJO. We'll talk about that. JSRS has been tremendously successful, but primarily has been a server-side API. Now we are adding a client-side API, kind of building upon same concepts. Default resources are very useful. If you are building a Java EE application, you're most likely building a database-driven application, or you're using some sort of a JMS service as well. Now the idea is, instead of building or creating a JDBC resource, which would be used in a JPA persistence unit, we are providing a default resource for you, which you can leverage out of the box, thereby lowering the bar and giving you a simple, seamless out-of-the-box experience with Java EE 7. We're also introducing... Oh, that was a good climax. Yeah, thank you. Thank you for that. We are also adding more annotated POJOs. So, for example, this will significantly reduce your work of DevOps. So, for example, if you want to create a JMS connection factory, we are giving you, a default connection factory and some new annotations, which would allow you to inject them by default. And in JSF, not last but not the least, we have added a new feature called as Faces Flow. This is primarily picking up the technology that already exists for a while, but now sort of standardizing it. This is sort of my top 10 features for Java EE 7. But with that, let's kind of jump into more details for the platform itself. So the very first topic that I'm going to talk about is Java API for WebSocket. Now, Java API for WebSocket provides a standard API for building WebSocket endpoints, both client endpoints and server endpoints. WebSocket provides a full duplex bidirectional communication channel over a single TCP connection. That is sort of the biggest value proposition of it. It's a very lean protocol, highly efficient, works very well for real-time real-time data communication over internet. There are multiple implementations available, but with this introduction of the API in the Java EE 7 platform, you can just take a POJO, as shown on the code on the bottom right. You can just take a POJO, put an annotation on it, say add server endpoint, and specify the URL at which this WebSocket endpoint is listening, and that's about it. No deployment descriptors, nothing else is required. That converts the POJO into a WebSocket endpoint. Now, a WebSocket endpoint receives a payload or an inbound message. Then you tag a message using @onMessage annotation. Okay, this is the message, that business method that needs to be invoked when my WebSocket payload is being received. So it's very simple, very intuitive. Not just server endpoint, but WebSocket is sort of a peer-to-peer protocol, not truly peer-to-peer, because it's primarily hub and spoke model where all clients connect to a server and then server broadcast to the client. But there is a concept of WebSocket listening for connection, or WebSocket being a peer to server. So we have, that's the way we have server endpoint, we have a client endpoint annotation as well. All of this could be done programmatically as well by extending abstract class. This gives you a little bit more programmatic configuration. For example, handshake and protocol can be negotiated, etc. Now, there are standard callback handlers available for WebSocket. So, for example, on close, on open, on error, on message, we already talked about. But if a WebSocket connection is open, call the on open. If there is an error on the connection, then call on error. So there are standard lifecycle methods available. And of course, the JSRS, which is a code sample shown over here, this can be very conveniently packaged in your WAR file, or if you have a client endpoint, that could be conveniently packaged in your application jar, or even in an ER file. All of those standard packaging models are there. We're not defining any new, just leveraging the existing packaging model and getting it through. So that makes it really simple and intuitive, and it fits very well with the rest of the Java EE 7 technologies. Moving on to slide 8, let me show a little bit more elaborate sample. I say elaborate, but it's very terse, but very powerful. So this is sort of a canonical chat server that you can think about for Java API for WebSocket 1.0. I have simple chat bean. Once again, I have an add server endpoint, and saying /chat is the URL where I'm listening. Then I'm saying, okay, this is, I have a set of session. Now, session is the other end of the connection, which is actually making a connection to the server, for example. Now, this is server endpoint, so this is deployed on the server side. So session in this case is going to be my client endpoint. I talked briefly about my callback handlers, on open, on close. So you can see whenever a WebSocket connection is being opened, my on open method is being called. Similarly, when the connection is closed, my on close method is being called. Now, in this case, what is every time a connection is opened, and I am capturing the session, which is automatically injected for me as a method parameter, and I'm to my set of session. So all that information is available to me at any given point of time in the set that, okay, which clients are connected or not connected at this point of time. Actually, which clients are connected effectively. If I go to slide 9, that is a very simple way by which I can start broadcasting my messages to all the connected, for example. I just say at on message. My very first method, which is string message, is the payload. And all I say is, okay, this is the client connecting to me, broadcast the message to all the clients that are connected to me. So very simple, but yet very powerful. And literally, this is a fully functional chat server. You just need to write a front end, which doesn't matter because it's using a standard WebSocket protocol. So any web-based protocol would work with it. Slide 10. Now, JSON processing. JSON is definitely the lingua franca of the web. It's a lightweight data exchange format, which is used pretty extensively all around. Today, when people have to, in Java, then they have to create third-party libraries, whether it's processing or generation of JSON. Now, that adds to the overall size of their application. Even though the library may be small, but then the library may have dependency on some parsers and generators, so on and so forth. So the overall size of the WAR file or application archive becomes bigger. With JSON API part of the platform itself, now this is available to you as part of the runtime. That means the application server itself provides it. What are we giving as part of the JSON processing API 1.0? There is a streaming API, which would allow you to read a JSON structure. It's a very low-level, efficient way to parse JSON. Of course, parse and generate JSON. Now, in terms of parsing, what happens is it reads a JSON structure, and now we know that JSON is a set of key value pairs. So it generates elements such as key name, key value, and if it's a value, then we know it's a string value or an int value, whether it's a start of an array or end of an array, and so forth. So just like Stacks API in the XML world, it's saying, okay, I'm going to publish those events. If you're interested in those events, you tap in those events and get value out of them. And I'll show you a sample code which will explain that better. Now, that is part of the streaming API. Just like DOM API in the XML world, we have an object model API as well. This object model API builds on top of the streaming API. It's a high-level API, and it deals literally at the object and the array level. The big difference between the streaming and the object model API is streaming API is more efficient. If you know exactly what elements. Okay. If you do not know, if you do not want to read the entire JSON structure in the memory, and you want to parse it more efficiently, just get the particular events and then handle them. That's when streaming API is useful. In terms of object model API, you are reading the entire JSON structure in the memory, but once you have read the entire JSON structure in the memory, then you can index into the object very easily. For example, you can say, give me this particular element, or this particular array, and all those things are possible. So that's sort of a trade-off that you make between streaming and object model API, completely driven by your use case. Going to slide 11, what I'm showing you is a simple JSON fragment. Now, as you can see, it is a set of name-value pairs. So my name being first name, value being John. The second name-value pair has last name Smith. Third name-value pair has age 25. And then the last name-value pair has a name as phone number and value is an array. Now, if I were to parse this using API, then I would just say, I will get a JSON parser. From the parser, I will get an iterator. Iterator is of the type of the event. And then the iterator, I will say, give me the next 3 events. Now, if I were to say next 3 times, the very first next says start of the object, which is right before the first opening parenthesis. Then I say iterator.next. Then I get to the beginning of the key name, which is literally right before the quotes of first name. And then I say another next, then it goes right before the quotes of the second name. And at that point of time, when I tell parser, give me the string, it actually returns the string value. That's the way this streaming API works. Very efficient and works very well as well. And most importantly, integrated as part of the platform itself. Slide 12. Batch applications for Java Platform 1.0. This is again yet a brand new addition to the Java EE 7 platform. We all know the purpose of batch. We have been using it for a very long time. It's very well suited for a non-interactive, that means there is no interaction required on the user part. Bulk-oriented, that means either you're dealing with the whole bulk of items at one point of time, and typically long-running tasks. Because it's bulk-oriented, typically it would take a little bit longer to run. So those are sort of the key aspects of a batch applications. Now, the batch execution of the task itself could be done in serial or could be done in parallel. It could be decision-based, like a workflow, that if this job does not succeed, do this job, things. So all of those are typical attributes of a typical batch application. Now, in terms of batch applications for Java platform, there are 2 processing styles that it recommends. The first one is the chunked processing style, which is the preferred or the primary processing style. Chunked is an item-oriented processing style. That means you read an item, you process an item, you give it to a writer for an aggregation. A typical example is, let's say you want to generate email statement, monthly email statement. Then you will read a record from a database, for example. Then you will process it, if there are monthly statement, generation of monthly statement. And then you will maybe give it to an aggregator, say a writer, which would say, okay, I'm going to send 200 emails at a point. So you will read, process, keep doing that for 200 times, give it to an aggregator, and then the aggregator will send out 200 emails at one point of time. And that 200 is called as the chunk size. And all of that is done within a transaction with inherent capabilities of checkpointing, etc., all of that. So that works very well. And all of that is provided to you by the batch runtime itself. And I'll show you how do you define the batch itself. Now that's the item-oriented processing. There is a task-oriented processing as well called as batchlet, where you can roll your own custom batch task. But the typical use I've seen is chunk processing style. Now, if we go to the next slide, it kind of explains what the key batch concepts are. Now, this slide is animated, and when I will share the slides as part of the technical kit, you will actually have the PPTX, so you can actually run through the presentation with complete speaker notes. But if you were to look at the slide 13, then you see there's a job repository, which is sort of the metadata for all the jobs. Then there is a job operator on the left side, which manages the batch process, which says, okay, I'm going to pick a job from the job repository. Then a job will have a step, which is sort of an independent sequential phase of a job. You can have multiple steps in a job, and what I'm showing you here is a job will have one item reader, one item processor, and an item writer. Actually, in this case, item processor should really be optional. It need not be available. And I won't go into the details. But together, reader, processor, and writer makes a chunk for me. Jumping onto slide 14, the job XML or the job is specified using a job specification language. In terms of batch applications 1.0, this is all defined using an XML document. And what I'm showing you on the top left is how a job would look like. I'm showing you a simple step with a logical ID saying send statements. This is a chunk step. I'm also saying item count 3, basically saying that, okay, I'm going to process 3 items at a given point of time. This chunk also has a reader, a processor, and a writer. Now, in terms of reader, if you see, or actually in all 3 batch artifacts, reader, processor, and writer, there are references that are available. These are really the CDI bean names of the POJOs that are available as part of your WAR file. They implement particular interface or extend abstract classes, and they have an @name annotation. So that way it's very well integrated with CDI. In case of a reader, for example, you can see there's a read item object, which would read account information using JPA. And I'm using the same analogy of sending a monthly email statement. Then I have an item processor, which has a process items element, which is where I'm reading an account and returning an object, which is a statement object. Now this statement object that is being returned is automatically being aggregated in my item writer, which is what my list is. So again, this is done automatically. You don't have to do anything explicitly. If you return the statement from process items and the reader, processor, and writer are specified correctly in the job XML, all this aggregation happens automatically for you. And then finally, in write items, which is my item writer, use Java Mail to send the email. So pretty straightforward that way. Now, of course, I'm showing you a very trivial job XML here. Typically, you will have many more steps with a lot more complex workflows, and all of that is definitely possible. Now, in batch 1.0, this can only be specified using job XML. It was discussed in the expert group that, should we do this via annotations, but that idea was rejected because the job XML itself could be pretty extensive, and to be able to capture all of that as part of annotations would be a very extensive task. Want to make sure we do the right thing first. Now, this may be dealt with in a subsequent version of batch, though. One more new specification that is getting added to the Java EE 7 platform is concurrency utilities. Now, this is simply an extension of Java SE concurrency utilities, and it allows you to give asynchronous capabilities to Java EE application components. If you realize in Java EE 7, we have several async components. We have JSRS client and server async. We have AJB async. We have Servlet async. But those are all container level async, as in the container handles the asynchronous part of it. This is really truly to your application on how you want to build your asynchronous capability. This is a low-level infrastructure component on which you can build your own asynchronous capability very easily. So, for example, think about you have multiple tasks that are in runnable or callable tasks. You can easily schedule them or easily use them using this concurrency utilities. Now, to support that, concurrency utilities provide 4 types of managed objects. The first 3, which is manage executor service, manage schedule executor service, and manage thread factory, correspond to the Java SE concurrency utilities. Context service is a new managed object that has been added to the platform, and it allows you to propagate the context to any of your application components. The very useful part of concurrency utilities is, even though your application or your task is defined as runnable or callable, all the context is propagated. So that is your JNDI context, your security context, your class loading context, all of that is explicitly propagated to the task or to the thread, except the transaction context is not being propagated. The primary reason for that is because, coordinating the transaction across multiple threads is going to be a lot more tricky. So that's the reason transaction context was explicitly ruled out to be propagated. Let's take a look at an example for how would a concurrency utility look like. So on slide 16, for example, I'm showing you a simple servlet. At the bottom, you can see there's a my task which implements runnable. All of the code of your application logic or your task logic would be in the run public void run method. And just using your standard, your Java SE APIs, you could say, okay, I want to inject a default managed executor service. Now remember, here I'm using a default resource. This resource is available to you as part of the Java EE 7 runtime, but you can of course inject your own resource as well, by giving a JIND reference in your web XML if you want to. Here I'm just saying manage executor service, and then on the executor I say submit my new task. The usage of plain executor service is not permitted in a Java EE application because Java EE is a managed environment. By giving a managed executor service, we give you that ability as part of the Java EE runtime now. All right, so those are the 4 new specifications, namely WebSocket, JSON, batch, and concurrency. Those are 4 brand new additions to the Java EE 7 platform. Let's take a look at how we have extensively aligned the platform and simplified it in other, as we were talking in the broader themes earlier. So this is one of the big areas where we have improved significantly over, because the last version of JMS was literally about 10 years ago. So now with JMS 2.0, what we've done is we have introduced a new JMS context interface. This is a new interface which essentially captures your connection and session objects. So if instead of dealing with connection and session, you can just deal with JMS context. And I'll show you a code sample which will clarify that a little bit more. We're also using auto-closure, which allows us to make JMS context, connection, session, all of these objects to be simply auto-closable and actually be used within a trie with resources very easily. And I'll show you how that impacts our programming model. We're also making use of runtime exceptions. So instead of using checked exception, make use of runtime exception. So let the programmer take charge of whether they want to catch the exception and deal with it or not. And the advantage of that is, again, simplified programming model and less boilerplate code. Extensive use of method chaining on JMS producer, where you can just use a fluent API, built on top of each other. And of course, a simplified message sending. For example, in the earlier version of JMS, we had this redundant parameters which were ignored if you were using them within an EJB. Those have been extremely simplified. And there are many such use cases like that. Jumping to slide 18. Is there a question? Oh, okay. So on slide 18, I'm showing you the code that is required to send a message using JMS 1.1. Now, you may try to read the code, but it's a lot of code to read, but understand. The 3 main points that I want to highlight here is, for example, first of all, at the top, I'm creating application-specific resources. I need to be explicitly aware of them and create them before even my application can run. Second is my boilerplate code. Just the way JMS 1.1 API is written, I have to make sure I honor that. And the API, if you think about it or you look at it, I get my connection. From there, I get my session, from which I get my producer, from which I get my text message.
What does it mean?
Is it?
Oh, can people mute their phones, please?
And then from the message producer, I finally send the text message. And if you look at it, there's a lot of exception handling that's happening towards the bottom of the slide as well. For example, I'm catching the runtime checked exception, and when I close the connection, even then I need to do exception handling. So let's take a look at slide 19 and see how this has been drastically improved. You can see the variation between slide 18 and 19. Just look at the font size itself. That itself gives you an idea of how much reduced lines of code we are writing. First of all, we're making use of dependency injection here. We are injecting the JMS context, which I said is a new object that we've introduced. So I just inject the JMS context. Here I'm injecting, now remember, I'm not even specifying what my connection factory is going to be here, because JMS 2.0 says if you do not specify a connection factory, a default resource connection factory is automatically injected for you. So once again, further simplifying the code that you write. Then here I'm injecting my application-specific destination. And again, there is a new annotation available for that, which would simplify your DevOps operation, where you can say, automatically create this destination, that is, add JMS destination definition. You can specify that definition or that annotation on your EJB or Servlet, and that destination is automatically created for you, which is then utilized in the add resource annotation here. And finally, the send message method, which is where I actually send the payload. You take a look at it. I'm just using my context. From the context, I create the producer, and then there I send the message to my destination and the payload. So think about all the things that I said earlier. Method chaining on JMS producer. So I'm saying producer.send, simple method. Simplified message sending. Very simple, very clean, easy to read. There are no checked exceptions here. The as context, connection, etc. All of those are auto-closable. So they, as soon as you go out of scope, they are automatically closed. So not only this simplifies your code, but it highly improves the semantic readability of your code. You just look at the code and you know what it is. Okay. Slide 20. Let's talk about Java API for RESTful web services. Now, the first version of JSRS, or actually the last version of JSRS, which is JSRS 1.1, the focus primarily was on doing server-side endpoint development. It was primarily a server-side API. So there are some big additions to JSRS 2.0. First of all is a client API. Now, typically, if you were to invoke a REST endpoint, you would use a low-level HTTP URL connection to connect to the endpoint, set up the metadata, get the response back, and then process the response, error handling, all of that. Now, that's, again, a lot of boilerplate code that you have to write. What we are doing now is overly simplifying that. And I will show you a sample for that, which will clean up the concepts. We're also adding server-side and client-side request and response processing hooks. These are extension points which allows you to address your cross-cutting concerns. So, for example, in a JSRS request and response, let's say you want to deal with gzipping and un-gzipping your payload, or doing logging of your messages or headers. So that's exactly where filters and interceptors come in very handy. And this is a very powerful concept, I would say, which is an extension point and really allows you to modify or your entire request processing life cycle. Scalability is, again, a big focus as part of JSRS 2.0. We don't want our servers to be greedy, not even our threads to be greedy, or even our applications to be greedy. So the idea is if you know your request or your resource or your client would take a long time to process, then you can, this is exactly where you can use your concurrency utilities. You can spin off your actual task execution in a separate thread, and a typical suspend and resume design pattern is being followed. That means, think about server side. So you receive a request, and let's say you know the database query, or you need to do some processing which is going to take a few seconds. You don't want to hold on to the server thread for those few seconds. All you do is you suspend the request by marking the method as asynchronous. Then you use a concurrency manage executor service. You delegate the task to the manage executor service. When the task returns, you resume and return the response back to the client. Same thing on the client. On the client side, you have a future object which allows you to query if the server side is done processing and get the result when required. Now, both client and server side asynchronous request and response processing is completely independent of each other. So you can make just the client side asynchronous or the server side asynchronous. We're also doing some improvements to JSRS 2.0, which is going to further reduce the amount of boilerplate code that you need to write. So typically, let's say you want to set a bunch of features on JSRS or a bunch of properties on a REST endpoint. You can encapsulate them as a feature, and which will further reduce your boilerplate code. Looking at slide 21, I'm showing you how the client API is extremely simple. Now, here I'm saying, for example, client builder is my entry point to the client API. There I say, okay, I got a client builder. From the client builder, I'm going to create a new client instance. Once you get a new client instance, on that, you can set a target. Target is the URI of the REST endpoint. Once you set the target, let's say in this case, I have a variable path, which is /orders/order ID. Now remember, order ID is within curly parentheses. That means it's a variable part. So that means I need to specify the actual value during the invocation or before the invocation. which is exactly what is being done in resolve template. So typically, I would expect that you will have a client.target set, and then you will call this, at different places by calling resolve template and invoking the request. Once you resolve the template, you can specify name value pairs, which are query parameters to the URL or URI, build a request using request, and then fire a HTTP GET method by calling GET. And of course, you can specify your type information. In this case, is string.class, so I get a string response back. This could very well be a POJO object. Of course, you can extend how your POJO object, is converted from on-the-wire format. So let's say your on-the-wire format is XML, then you can use a simple XML root element annotation, which would allow you to convert from XML to POJO and vice versa. Similarly, you can also use JSON processing API to convert from JSON structure to a POJO as well. So all of those mechanisms are very much part of the JSRS specification. Looking at slide 22. CDI was probably one of the biggest additions to Java EE 6 platform. Adding the dependency injection support in the platform itself was very long awaited and got really great reviews. Based upon a feedback from 1,100 of participants all around the world, we decided to enable context and dependency injection by default in the platform. That means, like in Java EE 6, you required a beans.xml to be available. Now, beans.xml is optional. So if there is no beans.xml, any bean with a bean defining annotation, so to say, which has a scoped annotation, a CDI scope annotation, would be automatically a target for an injection. Any EJB would be automatically a target for injection. So once again, CDI is enabled by default. No beans.xml is required. If you do have beans.xml, then we have added a new attribute in beans.xml, which is called as bean discovery mode. And in that bean discovery mode, you can say all. That means all beans are available for injection, independent of annotation, scope, or nothing. All of those beans are available. Or you can say types with only bean defining annotation. So you can say annotated, or you can completely disable CDI, even though you have beans.xml available. So there are different modes available, and you can play around with them. But the key part that you want to understand is we have ability to, or we have the capability to enable, we have enabled CDI by default for you. Some other improvements to CDI is where you can programmatically disable classes for injection by adding @vetoed annotation. This has been available in other frameworks and now integrated in CDI. We also enable global ordering and priority of interceptors and decorators. Looking at slide 23, bean validation 1.1. Bean validation was again a new specification added to Java EE 6. It allowed you to specify validation constraints on your POJOs, which were then validated at runtime. And if the constraints are not validated or not valid, a constraint violation exception was thrown. In the first version, it actually showed an integration with JPA, Java Persistence API, and JSF, or JavaServer Faces. Now, bean validation is much more tightly integrated with dependency injection. So literally, it can be specified on any POJO. So if you have a POJO, on any method of that POJO, you can specify validation constraints. Even on the return values, you can specify that. So the advantage of that is you can check pre and post conditions. That is, if you specify validation constraint on a method, if the preconditions are not met, the method is not even invoked. Instead, a constraint violation exception is being thrown. Similarly, if you specify a constraint on the return type, and the return type is not valid, the response is not returned, but a constraint violation exception is thrown. And something new that we have added as part of bean validation, as part of the existing alignment, is how you can specify validation constraints on your JSRS endpoints very well as well. So that's something new added to part of JSRS 1.1. Looking at slide 24, I just show you a simple sample on how you can do method parameter and result validation. So let's say I have a simple method called as place order. Now in the place order, I have three parameters, say string product name, integer quantity, and string customer. On the first two parameters, I could specify the annotations such as @not-null. That means I don't want this product. I don't want this parameters to be null. In the second one, I've also said @max10. That means the integer cannot be more than 10. So you don't want to order more than 10 quantities of a particular product. And then in the third parameter, I'm also specifying @customer. Now that is my custom-defined bean validation constraint, which says that, okay, I'm going to define what this annotation or this constraint really means, which completely my application specific. So all those mechanisms that are available in bean validation are available to you right here in your method parameter validation. Similarly, in result validation, like on the bottom of the screen, you can see, for example, or on the bottom of slide 24, you can see I have a public date get appointment. I want to get an appointment date in the future. Or if I just specify the constraint over there saying @future, that means it applies to the result value. And if the result value is not in future by your existing JVM, a constraint violation exception is thrown. Looking at slide 25, Java Persistence API 2.1. Several small ticket items added over there, one of them being schema generation. For example, JPA allows you to take a database table and say how it's going to get mapped to a JPA entity. So all of that was available for a very long time. Now, if you want to say, I have my JPA entity defined, from that I want to generate database table, there was no standard way of doing it. Although existing persistence provider provided a mechanism by which that can be done, but now we are providing a standard mechanism, and that is primarily done using JavaX persistence schema generation.star properties. All of these properties can be specified in your persistence.xml, and in the persistence.xml you define, at the runtime, I want the persistence provider to take a look at my JPA entity and generate the database table. Or ignore the database entity. Here are my scripts that are bundled with my WAR file. Take those scripts, use those scripts to generate the database table. Think about the use case here. For example, you may iterate over, taking a database table or starting the modeling of your application using JPA entities. From that, you generate database table or your scripts. You tune the scripts, and then you bundle the scripts with your application. Now, that is a very powerful model because you start with JPA entity, generate database tables, tune the scripts, you generate the JPA entities again, map them again. So you can do a full round trip effectively if you want to, depending upon how your structures are created, and that would really allow you to simplify your programming model. We are also adding support for unsynchronized persistence context. By default, a persistence context is synchronized. That means as soon as a transaction is committed, everything that was written to the persistence context is automatically committed to the underlying data store. Now, with the unsynchronized persistence context, you can detach a persistence context, and then you can say, I'm going to explicitly join a transaction and commit it when I need to. This is a good use case, specifically in offline use cases. So let's say you are using an application on an iPad or on a mobile phone, which is connected to unsynchronized persistence context. You can make all the changes to your persistence context, and whenever you get next connectivity, then you can synchronize it and explicitly join the transaction and commit changes. So I think a very powerful feature. Criteria API has been updated to include update and delete. The first version only had a read. We are also allowing ability to call user-defined functions and stored procedures, a standard way to do that now. Servlet 3.1, again, some small ticket items, but very powerful that have been added over there, addressing our scalability needs. Now, in Servlet 3.0, you could do I/O, but that was blocking. That means if in a Servlet do get method, you want to read input from an Servlet input stream, that would be done in a completely blocking manner. Now, if a client forgets to close the stream, then you will have to wait for the connection timeout, or if too much data is being sent or sporadic data is being sent, then you're really, again, blocking the thread. By using really JDK and IO2, we are making it simple and making it much more scalable. And I'll show you a code sample for that. We are providing a standard mechanism by which you can upgrade protocol. This is actually being utilized by WebSockets, for example. We're also making security enhancements. So, for example, you can, in your web XML, you can define which HTTP methods are going to be covered by particular security constraint. Now, by default, only the methods that are defined by the constraint are covered. Everything else is uncovered. That means they can be invoked. By adding a simple method called as deny uncovered HTTP methods, or actually a simple element to your web XML, you're saying, I'm going to make my application much more tighter for security. I can just say deny uncovered HTTP methods, and that's it. That will make sure that all my HTTP methods are protected now. Looking at slide 27, this is what I was talking about, non-blocking IO traditional sense. So I have a servlet. In my doGet method, I'm reading the response. Here I'm completely blocked, waiting for the client to close the stream or connection to timeout or something like that. Once again, we are using a suspend and resume pattern. Slide 28 shows in an asynchronous servlet how I can set up a read listener. That's a new interface that has been added to Servlet 3.1. And in Servlet 3.1, I'm showing you how in my read listener I have an on data available method, which is saying this, the implementation of this interface will be automatically invoked if data is made available. And then I will read the input, and then I will act upon it. Once again, simple suspend and resume, but gives you highly scalable application. Talking a little bit about JavaServer Faces 2.2, slide 30. A new big ticket item added to over there is Faces Flow. Faces Flow allows you to create reusable modules of part of your application, which can be used as a flow. Flow, for example, think of it as a checkout cart. You have a page where you have a shopping cart, then you can add your address, then you can add your credit card details, and finally a confirmation page, so on and so forth. So you can do things like that. Now that's a very commonly reusable module that you may want to use across your applications or different applications. So this concept has also been available in ADF, TaskFlow, or even in Apache MyFaces or other implementations. Now this is standardized as part of JSF 2.2. Effectively what it says is how you can take your XHTML, CSS, resources, backing beans, all of them together and package them as a module, as a jar file, which can then be utilized across different applications. So it's a very powerful feature, promoting modularity and reusability. Resource library contacts, once again, a step in that direction, which says how you can package the look and feel of your application as a zip file, and then provide a consistent look and feel across your applications, across, say, a corporate template. So you can bundle your templates in a jar file, bundle them as part of your application, and then reuse it instead of copy-pasting the code. So truly following the dry principle of don't repeat yourself. HTML5 added type attributes, wherein for an input element, you can specify what the type of the element is going to be. Could be a number, could be a telephone, could be an email, could be a URL, and those are standard HTML5 type attributes. And then there are certain data star attributes. These data star attributes are application specific and accessible to the JavaScript, for example. Now, for JSF for JSF in general, any attribute that is not understood by the JSF runtime, specifically UI component and renderer, are ignored. Now, JSF 2.2 adds a new pass-through element and attribute, which says, okay, you know what, this particular attribute on the element is a pass-through attribute. That means I don't understand how to deal with it, and let the browser render it accordingly. So any HTML5 capable browser is fully capable of rendering those HTML5 type and data star attributes. I just need to mark it as a pass-through attribute in a h:\input text, for example, and that makes it a pass-through attribute. And then eventually the browser, like Chrome, for example, would render it correctly. Some other small ticket items as well. One of them that I want to highlight here is how we have the ability to add, upload an input file very easily. On slide 31, this is, I think, a very significant feature that is added to the platform, Java Transaction API 1.2. We have extracted the semantics from EJB, or the transactional semantics specifically from EJB, and allowed them to be used more widely on a set of CDI beans. So, for example, if you have a POJO, on a POJO, you can easily specify @transactional attribute. Then all methods in that POJO automatically become transactional. And this is completely implemented using standard CDI interceptor bindings. That means there is nothing you need to do. This is not an application-specific annotation. This is in JavaX package, so you just use the annotation. If you do it on a class, all methods in the class become transactional. If you do it on a method, that particular method becomes a transactional. So you no longer have to use EJB if you want to use transactions. You can just use that transactional annotation. And then we have a new CDI scope called a transaction scoped. This basically ties the life cycle of a bean to a transaction. So a new instance of the bean is automatically created when a transaction is started and destroyed when the transaction completes. So these two generally go hand in hand very well. Coming to slide 32, now all the specifications, as I said in the beginning, all the specifications for Java EE 7 are completely final. All the specifications are also posted on the jcp.org website. The maintenance releases are about to get posted, but the specifications listed over here, what you see is called as a pancake diagram. It shows you sort of the typical three-tier architecture for Java EE 7, and all the specifications are posted over there. Highly encourage you to download them, try them. Slide 33, this is coming on June 12th. Java EE 7 SDK is where you will get the complete runtime for Java EE 7. Not just the runtime, but you'll have code, code samples, tutorials, docs, all of those available, along with just the bare vanilla Glassfish server. And of course, if you want just the Glassfish server, which is where the implementation is being built, you can say, I just want the web profile or the full platform. You can go to glassfish.org for downloading that. But that is going to be coming on June 12th, though, so hang in there. Up until then, what you can do is look at slide 34. I give you a URL which allows you to download the promoted builds. So build 89 is the last promoted build, which is going to be released as a final build. So highly encourage you to download it and try it. Slide 35, now we are not done yet. Well, Java EE 7 is done, but Java EE 8, these are some of the tentative themes that we are looking at on what we want to do in there. Cloud, providing a standards-based cloud programming model, focusing on JSON binding. Now, JSON API is only for processing. We want to provide a standard JSON binding API, doing state management, caching, NoSQL, some of the things that we are looking at. Again, nothing of this is committed at this point of time. It's completely dependent upon what the expert group thinks about it. Slide 36, we had tremendous success with Adopt-a-JSR effort. Many, many thank you to all the different Java user groups that participated as part of this process. You folks were absolutely fantastic in giving feedback, building sample applications, creating hackathons, filing bugs, giving all the feedback that is really, really important to build these standards. So I think that was tremendously useful. Now the work does not stop here. Now that the Java EE 7 is final, I will be working with different specification leads to highlight what is really important, what are the important features that we want you to look at as part of Java EE 7, and keep filing those bugs. Keep telling us what would you like to see in Java EE 8 in those different specifications. So we'd love to hear back from you on that. And then slide 37 is my last slide, really, which says, where you can download all the specs, or at least have a pointer to the specs, the implementation, the blog URL, the Twitter handle, and we also have NetBeans preview tooling that is available as well. almost there. The final set of release for NetBeans 7.3.1 will be available on June 12th once again, which will provide extensive Java EE 7 tooling. So I would say stay tuned and let us know.